Hello everyone, my name is Akhil Gogeri and today I am going to take you on a fascinating journey through one of the oldest and most mind-bending paradoxes in mathematics and philosophy. That is Zeno's paradox, famously known as the infinite chase. This paradox challenges our very understanding of motion, distance and infinity, and surprisingly, it's over 2500 years old. So who was Zeno? Zeno was a Greek philosopher who from 5th century BC who lived in Elia, Italy. He proposed a series of paradoxes aimed at defending his teacher Parmenides, who claimed that the motion was merely an illusion. Zeno crafted thought experiments to show that motion, when analyzed logically, leads to contradictions, and among these paradoxes, the most famous is the race between Achilles and the tortoise. Imagine Achilles, the legend Greek hero, racing against a slow moving tortoise. To make things interesting, the tortoise is given 100 meters head start. Achilles is much faster, let's say 10 times faster. So when Achilles reaches the 100-meter mark, the tortoise has moved 10 more meters. When Achilles reaches that point, the tortoise has moved another 1 meter. This process keeps repeating. Achilles gets closer, but the tortoise keeps moving ahead, always staying just out of reach. Zeno argued that Achilles can never overtake the tortoise. But why? Because every time he reaches the point where the tortoise was, the tortoise has already moved a little further ahead. The chase creates an infinite number of steps: 100 meters, then 10, then 1, then 0.1, and so on. No matter how small the steps get, there are infinitely many of them. So how can Achilles ever finish infinite number of steps? Let me give you another way to think about Zeno's idea. This time, let's use a square. Imagine you have a square which has area 1 unit. You cut it in half, then take one of the halves and cut it again in half. Then take the quarter and cut it again in half, and so on. While we are doing this, let's keep track of the areas of pieces. The slice makes two parts each. No matter how many times the boxes are sliced, the total area is still the sum of area of all the pieces. Here we obtain same infinite series as we had for the time of Achilles. As we take limit n tends to infinity, the entire square becomes blue. But the area of square is 1 unit, so the infinite sum must equal to 1. This is exactly what the Zeno's paradox is about. Even though the action seems infinite, like the steps Achilles takes, the total result can still be finite. Resolving the paradox. This is where modern mathematics steps in. Although the number of steps is infinite, the total distance and time involved is finite. The pattern 100 plus 10 plus 1 plus 0.1 is a geometric series. The sum of infinite series converges to 111.11 meters, which means Achilles catches the tortoise just after running over 111 meters. It's not about finishing infinity, it's about understanding that infinite steps can still add up to a finite result. Why it matters? Zeno's paradox isn't just a brain teaser, it forced people to confront the idea of infinity, not just as a number, but as a concept. This paradox laid the groundwork for calculus, especially the ideas of limits and convergence, which were formalized over 2000 years later by Newton and Leibniz. In today's world, these ideas power everything from physics to animation, from computing to artificial intelligence. To wrap up, Zeno's paradox teaches us that our intuition isn't always right. When it comes to abstract ideas like infinity and motion, Achilles does overtake the tortoise, but to understand how, we had to evolve our mathematics. Zeno helped ignite that journey, showing us that even the smallest questions can lead to the biggest discoveries. Thank you for watching. Have a great day.